Okay, now the next problem is a very long problem. It is again from the book of Dixon. Problem number is 4.2. It says a single stage gas turbine operates at its design condition with an actual absolute flow at entry and exit of the stage. This is the nozzle. This is the rotor. So it says axial absolute flow at entry and exit of the stage. Axial absolute flow at the entry and the exit. It's 1, 2, and 3. Okay, the absolute flow angle at nozzle exit is this is a single stage gas turbine. So at 2, the diagram would be something of this sort. This is U2, this is V2, this is W2. It says the absolute flow angle at nozzle exit is 70 degree. Nozzle exit is this and this is 70 degree. As per our derivations done earlier, this is alpha 2, which is equals to 20 degrees, right? At stage entry, the total pressure and temperature are, so P at stage entry, P01, because it is the total 311 kilopascal, and T01 is 850 degrees centigrade, which is equals to 1123 Kelvin. 1123 Kelvin. Okay. The exhaust static pressure is 100 kilopascal. So P3 is 100. The total to static efficiency is 0.87, and the mean blade speed U is equals to 500 meter per second. Okay, first we have to find out specific work done. Specific work done, delta W is given by VU2, since it is a turbine, VU1 minus VU2 into U. Since the flow is axial, so VU2, here it will be VU2 and VU3, because the inlet to the rotor is 2 and 3 is the outlet. This is 0 since it is axial. So this is the normal diagram that we draw. Since it is perpendicular, so it is actually like this, and there is no VU2 component. It's 0, right? So this is 0. Now we are also given Cp is 1.148 kilojoule per kg Kelvin, and gamma is 1.33. Okay, so the specific work done is given by this, but here we can say that at this point T01 equals to T02 because it is a nozzle. So at this point also the temperature is 1.23 T02, okay, Kelvin. Efficiency total to static is equals to T01 minus T3 by T03S minus T0 minus T03S, and this is T1. It's T3S because it is static. So let me draw the HS diagram. Enthalpy entropy diagram. So this is 1, 2, 3. This is nozzle. This is how it looks. This is pressure 2. This is pressure 1. This is 3. This is 2. This is 1. This is 2S. This is 3 double S. This is 3 double S. Okay. This is 3S. Now we know T01. We have to find out. We can find out this 3 double S because this is isentropic process, and if we find 0, 1 also, this entire thing will be a isentropic process. Okay, so we can find out T3SS from here. This is known, so we can find out this. Okay, over here what I have missed is that the efficiency is called total to static. This is the total T01 minus T03. T01 is 0, okay, and stagnation minus T3SS. This is actually H01 minus H03 divided by T01 Cp into T01 T3SS. This is delta W. We need to find T3SS. T3SS divided by T01 equals to P3 by P01 to the power of gamma minus 1 by gamma. So T3SS divided by 1123. What is P3? P3 is 100. And what is P01? P01 is 311. So 0.33 by 1.33, we find T3SS is equals to 847.45 Kelvin, right? So efficiency 0.87 is equals to delta W divided by Cp. Cp value is 1148 into T01. How much is this T01? It is 1123 minus 847.45. 123 minus 847.45 into 1148 into 0.87. It gives me delta W equals to 275.204 kilojoule per kg. This is one answer. The second question is Mach number leaving the nozzle at 2. So as I have told over here, this delta W is equals to VU2 into U. Two 204 is equals to VU2. This is VU2. And U is 500. So VU2 is 550.41 meter per second, right? From here we can find out V2, since the angle is 20 degrees. So this is 20 degree. We know this VU2. We have to find this. So VU2 by V is equals to cos 20 degree. So this divided by cos 20 degree, cos 20, 585. V equals to 585.73 meter per second. Okay, this is V2, right? You have to find T. T02 is equals to T01, which is equals to 1123. So T2 is 1123 minus V2 square by 2 square divided by 2. So into Cp. This is into Cp and this is into Cp. So 1123 into Cp is almost 1148 minus answer, okay, divided by 1148. So we have T2 is equals to 973.573 Kelvin. speed of sound is gamma RT. We will have gamma as 1.33. We can find out R, and T is 973.573. 1148 is CP. Gamma is 1.33. CV is 863.157. R is equals to CP minus CV, which is equals to 285. This is 285. 1.33 into 285 into 973.573. Square root 607 meter 0.48 meter per second. So Mach number is V2 by A, which is 585.73 divided by answer. Mach number is 90.964. Okay. Now the third question is the axial flow velocity. Very easy. Everything is given. This is 20 degree. We know VU2, we know V2. You have to find out this Vx. So Vx equals to V2 sine 20 degree. V2 is this 585.73. So 200. Vx equals to 200.33 meter per second. Okay. Go to number 4. Total to total efficiency. Efficiency total to total is equals to, if we see this, we can have another P03. Okay, and this is 03. So H01 minus H03 divided by H01 minus H03 S. T03 SI. Let's see. T01 is 1123. Okay, 1123. T3SS is equals to, this is 3SS, 847.45 Kelvin. So T3SS is equals to T03SS plus V3 squared by 2 Cp. So we have got V3, right? V3. V3 is axial, so this is only V3. So this divided by 2 divided by how much is CP? 1148. 1148. So T03SS is 864.93 Kelvin. Okay. To find out T03 as well. So T3. Do we know this T3? But we know delta W, right? So T3 is not required. This is delta W. So we have efficiency Dt is equals to delta W divided by Cp into 1123 minus 840, 864.93. Delta W is how much? 275.204 divided by 1148 divided by 1123 minus 840, 864.93. This gives me efficiency total 0.929. This answer is correct. The stage reaction R R for a turbine. Five by two cot minus cot. So this is the turbine. This is V1. This is W1. So beta 1 is beta 1, right? So this will be beta 1. So beta 2. So we have this is alpha 2. This is beta 2, right? And this outer triangle, this is V2, this is W2, so this is U, and this is W2. Okay. W3 actually. Anyways, let me make it beta 1. Okay, so we can change both these angles to alpha because both alphas are given, right? This is 90 degree and this is 20 degree. So to change this to alphas, how to do that? R equals to 5 by 2 WU2 by Vx WU1 by Vx. Let me draw the velocity triangle. This is V1, this is W1, this is U, this is V2, W2, so this is beta 2. So WU2, this is WU2, right? This is U plus VU2 minus WU1, this is WU1, this is VU1 minus U, this is VU1 minus U is WU1 by Vx and phi is Vx by U2 into U twice U by Vx plus VU2 is 1 plus phi by 2 plus phi by 2 into cot alpha 2 minus cot alpha 1. So cot alpha 1 is 20 degrees. Okay, this is 90 degree. So this is 0. Phi is Vx by U. Vx is 200.33. U is 500. U is how much? U is, let me see, U is 500. So we have got this phi is 200 divided by 500, 0.40066. 66 into minus 1 divided by 1020, 2.4774 into 40066. So this divided by 2. So R is 0.449. Okay, this is the answer.